Slope-intercept form, proportional or non-proportional? Non-proportional. The M is the, guys, y'all got to know that. The M is the slope. The B is the y-intercept. That is one of the main parts of your STAR test. All right, direct variation, proportional or non? Proportional. And you can solve direct variation by making the box. That's what you're drawing right here, is making a box. Okay, the section titled area is how you solve for big B. Okay, for a circle, you were supposed to draw 2 circles, one with the diameter, and it doesn't matter which order you put it in, as long as one is labeled correctly all the way across is the diameter, and what? Halfway across is the radius. But I don't care which one you put in which box. That doesn't matter. Just make sure all the way across is the diameter, halfway across is the radius. Okay, then go down to the section titled volume. You have to change the formula for cylinder and cone. What are you going to replace big B with? Pi r squared for both of them. So instead of big BH, it's pi r squared h. And instead of 1/3 BH, it's 1/3 pi r squared h. And then the last two, what are the 2 words that they're going to tell you for Pythagorean theorem? Distance or length. Okay, like I said, I want you guys to put an X on the ones you didn't know or got incorrect so that you know which ones to study tonight. You're going to keep this, okay, and you're going to go over it tonight. When is your quiz over this? Tomorrow. Okay, so today's lesson at the top, if you'll put 12-4, because this is the 4th lesson and the final lesson of transformations, and then we're finished with transformations. Okay, let's go over what we know so far. If y'all would, shut y'all's Chromebooks for me. Thank you. What is a transformation? And you think of the movie when you hear that word. What's a transformation? A change. The first type of change we learned was translation, and it was a slide. Did it change size? Did it change shape? Okay. The next one we learned was a reflection. It's a what? What'd I just do? A flip. Did it change size? Did it change shape? Okay, then yesterday we learned our third type, which was a rotation. It's basically just like a turn. That's it. Did it change size? Did it change shape? Okay, those 3 types of transformations preserve what? Congruence. They preserve congruence. They keep the shape the exact same side lengths, exact same angles. Are y'all good with that? Today we're moving on to what's called a dilation. A dilation is different from all the transformations we've learned so far because it does not preserve congruence. It's the only one that doesn't, okay? A dilation makes a shape, write this down, makes a shape bigger or smaller. A dilation makes a shape bigger or smaller. But the shape will still be proportional. So if you start with a square, it's still going to be a square. It's just going to be bigger or smaller. Okay? So do you see why dilations do not preserve congruence? Because what's the definition? They make the shape bigger or smaller. Congruent means they stay the same. So do y'all see how easy it is to know that dilations make a shape bigger or smaller? Have any of you guys ever been to the eye doctor? What do they do to your eyes? They dilate them. What does that mean? They put some drops in your eye, but what are they doing? What happens to your pupil? It gets really, really big because the eye doctor wants to be able to look into the back of your eye. So your pupil's like this little circle. It's the little black circle in the middle of your eye, right? When they put those drops in, the little circle in the middle of your eye goes like this. They do that. They dilate it. Did they change the shape of your eye, or did they just make it bigger? So whenever you think of dilation, you can think of the eye doctor dilating your eyes. It's making it bigger so that they can see back in your eye. Then they make you wear those glasses outside to protect you from the sun because your pupil's letting in too much light. That's what they're doing, okay? All right. To make a shape bigger or smaller, they use what's called a scale factor. A scale factor is a multiplier. Meaning, what are you going to do with it? Multiply, right? It's a multiplier. It determines, it tells you how much bigger or smaller to make the shape. A scale factor is always a multiplier. Did you know you can make a number smaller by multiplying? Did y'all know that? Most of you think you make a number bigger when you multiply, but I want to show you guys. Look at my calculator. If I multiply 10 times 2, is the number going to get bigger or smaller? Bigger. So that would be an enlargement because I multiplied and it got bigger. How do you multiply and make something smaller? You multiply by a fraction, right? A number that's less than 1. So everybody watch. If I multiply 10 by 20 cents, 0.2, isn't 20 cents less than 1? Look what happened to my 10. It got what? So you can use a scale factor as a multiplier and make a shape smaller. You can use a scale factor as a multiplier and make it bigger. It just depends on what you multiply by. Okay? Now, everybody skip the middle section real quick and go to the bottom. This is very, very important. Oh, no, it's right here in the middle. Does everybody see? If the scale factor is greater than 1, it's going to make it what? Bigger. Just like I showed y'all. 10 times 2 made it bigger and made it 20. But if the scale factor is less than 1, it's going to make a reduction. What does reduction mean? Smaller. Okay? Just like when I multiplied 10 times 0.2. Does everybody understand that? That will be a question on your STAR test. It'll say, which of the following would make a reduction? You pick the number less than 1. Which of the following would make an enlargement? You pick the number greater than 1. Are we all okay? Now, the most questions that are asked on dilations are about the rule. Do y'all remember how we've been doing the rule every single day? X, Y changes to this. So the rule is, and it's right here, that you multiply. So dilation's rule says that you multiply by the scale factor. So does everybody see A times X, A times Y? That A is your scale factor. So if I have a scale factor of 2, my rule would be 2 times X, 2 times Y. If I have a scale factor of 5, 5 times X, 5 times Y. That's all you do is just put the number as the multiplier. How do you find the scale factor? Right here is the most important part of today. New divided by old. Do y'all remember when we were learning about shapes on a coordinate grid, I told you the new shape has the little dashes, yes? And the old shape doesn't. So you just get a number from the new one, put it on top of the old one, and divide. And that's all you do to get the number. Okay? All right. Let's go do some examples. Look at the bottom at example 1. if a shape is dilated, so stop right there. You know that it's going to be what? Dilated means what? Made bigger or? All right. By a scale factor of 1/5, would the new shape be a reduction, meaning smaller, or enlargement, meaning bigger? So how am I going to determine this answer? I need to know if this number is greater than 1 or less than 1. So could I just change it to a decimal? So let's go change 1/5 to a decimal. Math decimal enter. So it's 0.2. Is 0.2 greater than 1 or less than 1? So would this make a reduction or enlargement? Reduction. And you will need your calculator today. Does everybody understand why that answer is reduction? If the scale factor is less than 1, your shape is going to be smaller. All right, look at the next example. If a shape is dilated by a scale factor of 3/2, would the new shape be a reduction or enlargement? Somebody tell me, what do I need to do? Change this to a? All right, let's go change it to a decimal. Everybody remembers how to do it, right? Alpha y equals option 1, 3/2, enter. Now what? Math decimal enter. So what is 3/2 as a decimal? Okay, remember, if it's greater than 1, it's an enlargement. If it's less than 1, it's a reduction. If it's less than 1, is this greater than 1 or less than 1? Greater. So what's my answer? Enlargement. Because if I was to multiply a number by 3/2, it would get bigger. And you can multiply any number by 3/2 and you'll see it gets bigger. Watch. 10 times 3/2, it's going to make 10 bigger. It made it 15. That's bigger than 10, right? So you could try it that way too. All right, any questions about if it's an enlargement or reduction? Yes or no? Now we're going to be given a picture and we have to write the rule. Okay, so flip to the back. Look at example 3. The hardest part of this is knowing which one was the original shape. So everybody better pay attention right now to what I'm saying. Figure S was dilated to create figure T. Which one's the new shape? How did you know? Well, hold on. Let's say that again. Figure S was dilated to create figure T. Which one is the new shape? T, because they created it. So everybody go label figure T the new one and figure S the old one. It is very, very important that you know which one's new, which one's old. They want you to write the transformation rule to describe the dilation. Well, the rule says take your X and Y and multiply it by a scale factor. So I'm looking for the number to multiply times X times Y. This is the number I'm looking for. To find that number, you're simply going to divide new divided by what? Old. There are so many ways that you can pick a number. I'm going to show y'all lots of different ways. So I'm going to zoom in. You can pick a coordinate. So does everybody see figure T is intersecting at 6? What is figure S intersecting at? So what's the new one? 6 over 3. You could also count side lengths. So do y'all see this side length right here, how it corresponds with this side length? I could count, okay, this side length is 1, 2, 3, 4. This side length is 1, 2. You will get the same answer. What's 6 divided by 3? What's 4 divided by 2? Do you see how it doesn't matter if I pick a coordinate, if I pick a side length, I'm going to get the same answer. So what is my scale factor? So my rule, all you do is drop that 2 in right there. So it would be 2 times x, 2 times y. So I take my x and my y, and I multiply them both by 2. Okay, I'm going to say it again. How did I get 2? Divide new divided by old. That's all you do. I want you guys to try example 4 on your own. First of all, you're going to figure out which one's the new circle, which one's the old circle. Everybody go do that right now and label them new and old. Okay, stop. It says circle 2 was dilated to what? Create circle 1. So which one's the new circle? Circle 1 is this one's new, this one's old. Did everybody get that part correct? Now all you had to do was divide new divided by old. Did y'all find some numbers that corresponded? Do y'all see right here, the old one passed through what? 8, and the new one passed through 3. So which number would go on top, 8 or 3? 3, because it belongs to the new. So 3 over 8. And guys, that's your answer. It doesn't simplify. It doesn't turn into a whole number. That's your scale factor. So if you wrote a rule, it would be take your x and y and multiply them by 3/8. Would this be an enlargement or reduction? Reduction, because 3/8 is less than 1. Right? And you could look right here and say, okay, they started with a big one and they made a small one. So obviously it's a reduction. All right, last thing I want y'all to do at the very bottom is let's write what's important. When I take a shape and I make it bigger or smaller, does it preserve congruence? No, write that. Does not preserve congruence. This is important. It's all over your assignment. Does not preserve congruence. Now, there is one thing that stays the same. The angles. The angles do stay congruent, and I'm going to explain that to you guys. Write that down because that's a question on your paper today. The angles do stay congruent. Okay, and I'm going to show y'all real quick. Y'all don't have to draw this. If I have a square, what kind of angles are these? What kind of angles are these? Right. If I make this square bigger, what kind of angles do I still have? So when you make a shape bigger or smaller, the angles stay the... Do y'all understand that? But do the sides stay the same? If this side was 2 and this side's 4, are they the same? Absolutely not. So the sides are not congruent, but they are, this is the word they're going to use, the sides are proportional. Meaning when they make it bigger, it stays the exact same shape, they just got bigger or smaller. All right, let's say it again. Dilations do not preserve congruence. However, the angles do stay congruent. The side lengths are proportional. This is about 3 questions on your assignment today. The rest is all new over old. Okay, I'm going to pass the assignment out, and then we'll go through and make sure y'all know how to set them up. Look at the assignment. Numbers 1, 2, and 3 are straight from these words that we wrote on the back of our notes. If you look at number 1, it wants to know if you dilate a shape, what happens to the angles? Well, we wrote it right there. Do y'all see it? I'm not going to say the answer, but I wrote it for you. Number 2 wants to know if you dilate a shape, what happens to the side lengths? And we wrote it right there. Okay? I literally gave you the answers word for word. Then on number 3, it wants you to put both of those pieces together and talk about the side lengths and the angles. So it's basically the answer to number 1 and 2 put together in one question. Now, let's look at number 4. This is the rest of the assignment is number 4. What are we learning today? Dilations. Look at the answer choices. 2 of them are not even dilation rules. Which answers are not dilation rules? A and C. Those are translation rules, if y'all remember that from last week. So on this whole paper, you can go through and mark those addition and subtraction rules off. To solve this problem, you're going to have to do new over old. Okay, now go to number 5. Number 5, to find your new and old, do you see the slashes? If it has slashes, that's the new one. If it doesn't, that's the old one. So they'll either tell you in words or it'll have slashes. Are y'all all good? So which 2 rules could I mark off on this one? Say it again. Which one can I mark out? H and J. And then I'm just doing new over old. Okay? All right, get busy. Let me know if you need help.